Hello, good morning, all of you. We are beginning with our General Studies 1, General Principles of Physical Geography. It has always been a sort of, I'll say, debate, mire, confusion among the students, because when we talk about geography, definition of geography essentially relate itself with terrestrial studies. What is geography? Geography is study of surface of Earth. And if I'm supposed to study terrestrial domain, why there should be the scope of topics like universe, solar system. It is something which is very elementary part of astronomical studies that makes part and parcel of geography. Sooner or later, we need to have the understanding of each one of them. तो एक general overview बहुत जरूरी है. That general overview, which is not required to make you get into the details of astronomy for sure. आप अपने main के question paper को देखें. I hardly get any question from the universe and solar system. Preliminary may still there is some of the presence of the questions from these topics. Second thing, when I take reference of climate, I need to be aware of sun as the source of heat energy. When I take reference of tides, I need to be aware of solar and lunar alignment and their gravitational pull on the surface of the earth, generating distinctive kind of tidal bulges. तो ignorance कहीं से भी advisable नहीं होता किसी भी point के preparation में. You should be aware of the things. एलिमेंट्री लेवल पर ही रखना है, इतने ही लेवल पर रखना है जितना आपके एनसीईआरटी में दिया हुआ है. आपको उससे ज्यादा जाने की जरूरत नहीं है. एंड आई एम वेरी क्लियरली एम्फसाइजिंग उससे ज्यादा जाने की जरूरत नहीं है. What exactly we are willing to take into reference in today's session? The general overview of universe and solar system. Solar system, the planetary system as it is called. So whenever we talk about universe को आप जैसे define करते हैं, I have taken some of the important information slides here, ताकि we can easily concentrate on understanding the things rather than getting on to writing stuff. Expanding universe की जब आप बात करते हो ना, तो it is an explosion in space. No. एक जनरल डिमार्केशन रहता है जब हम कहते हैं ना हाउ यूनिवर्स वाज फॉर्म. सो द मोस्ट डिफाइंड अप्रोच थियरी इज बिग बैंग थियरी. वो जस्टिफाई करता है that there was a big bang, there was an explosion. So is this explosion that has taken place in space? नहीं, ये याद रखना हमेशा, is an expansion of space itself. These are the important things that makes and breaks our statement comprehension in preliminary examination. As I said in the very beginning, इस टॉपिक को आप एक फाउंडेशन बनाकर समझिए. इस टॉपिक को आप एक बेस क्रिएट करने के लिए समझिए, जिसके ओरिएंटेशन पर we will build up the ever evolving characteristics of planet Earth. That is what is salient feature of physical principles of geography. So ever expanding universe के बारे में जब बात करेंगे, तो ये सबसे important चीज जो आपको justify करनी होगी, वो करनी होगी what is universe. So when I take reference of what is universe, let it come like this. I identify it to be, and our definition itself is very elaborate, and we should consider it in complete sense. किसी भी point पर availability of notes and writing stuff is, there is no doubt. The universe is the total collection of space, time, matter, energy, and the physical laws that governs them. The universe relates itself to everything. ठीक है? It is not just stars and galaxies, अभी थोड़ा सा डिटेल्स में ले जाएंगे, but also the invisible components like dark matter and dark energy. Dark matter and dark energy are some of the elements of universe which are yet to be completely comprehended, yet to be completely analyzed, yet to be completely इंटरप्रेटेड. सारी चीजों को देखना पड़ेगा. यहीं पर जब आप बात करते हैं composition of atmosphere, I think it makes an important point. 5% ordinary matter. Ordinary. Only 5% is accounting for ordinary matter. Atoms, stars, planets, gas, life. Are you understanding? जिसको हम समझते हैं ना कि यूनिवर्स इज इक्वल टू प्लैनेट्स एंड स्टार्स, वो सिर्फ 5% रिप्रेजेंट कर रहा है. 27% जो आपका एसोसिएशन है वो डार्क मैटर से है, and 68 dark energy and mysterious forces. So universe is basically that I'll say entity. Universe is that elementary entity which is identified to be incorporating so many mysterious things that we are still evolving out, we are learning out. ये सारे pointers कहीं एक मल्टीपल चॉइस क्वेश्चन को हैंडल करने में मदद कर सकते हैं और एक फाउंडेशन बनाने में मदद कर सकते हैं. सो वी आर नॉट एक्सपैंडिंग इन स्पेस, वी आर एक्सपैंडिंग एंड द स्पेस इटसेल्फ इज एक्सपैंडिंग. और ये जो एक्सपैंडिंग यूनिवर्स है, इसमें जिस चीज को हम हमेशा प्रायोरिटी देते हैं, बिकॉज दैट इज समथिंग व्हिच वी आर एसोसिएटेड विद, दैट इज समथिंग व्हिच वी आर मोर अवेयर ऑफ, दैट अकाउंट्स ओनली फॉर 5% द ऑर्डिनरी मैटर. ऑर्डिनरी मैटर इसलिए बोलते हैं क्योंकि इट इज रिप्रेजेंटिंग वेरी स्मॉल शेयर, रिप्रेजेंटिंग वेरी माइनर शेयर ऑफ यूनिवर्स. कई बार बच्चों के दिमाग में डाउट आता है दैट वी आर नॉट फ्रॉम द साइंस बैकग्राउंड, तो हमें जब फिजिकल ज्योग्राफी पढ़ना पड़े, स्पेसिफिकली इस तरह के टॉपिक्स को हैंडल करना पड़े, वी डोंट फाइंड कॉन्फिडेंस. सो आई ऑलवेज से कि आपको किसी भी टॉपिक को प्रिपेयर करने के लिए सबसे पहले एनसीईआरटी का रेफरेंस लेना चाहिए. आपने जैसे एनसीईआरटी टेक्स्ट बुक को पिकअप किया एंड यू स्टार्ट रीडिंग ओरिजिन ऑफ सोलर सिस्टम यूनिवर्स, वो 2-4 पेजेस पढ़ते पढ़ते आपको अपने आप पता चलता है कि नो, आई एम नॉट सपोज टू बी से अवेयर ऑफ, कंफर्टेबल विद very typical scientific orientation of physics, to be in position of comprehending, to be in position of making sense with what is mentioned in my NCERT. It's very elementary. Or as targeting some competitive examination, उतनी elementary knowledge मेरे पास जरूर होनी चाहिए. आप उस पर्सपेक्टिव से इसकी तैयारी कीजिए. आप इस पर्सपेक्टिव से नहीं कीजिए कि मैं तो ह्यूमैनिटीज से हूं तो मैं फिजिक्स वाला ओरिएंटेशन कैसे ले. ये बहुत एलिमेंट्री कंटेंट है और इस एलिमेंट्री कंटेंट को हम सबको बहुत अच्छे से पिकअप करना चाहिए. सो व्हेन आई से यूनिवर्स इज एवर एक्सपैंडिंग, व्हाट अल्टीमेटली विल हैपन टू यूनिवर्स, वो ग्रेजुअली पहुंचते हैं वहां पर. सो इट इज कॉम्बिनेशन ऑफ मल्टीपल थिंग्स, एंड दिस कॉम्बिनेशन is where we justify, where we identify ordinary matter as the prime concern of ours. बाकी जितना percentage share है, I'll be attaching the link of the notes with it. So universe is the total connection. How do I define universe? It's the total connection of space, time, matter. And I go to here. This is, I think, somewhere important for us to apply. And taking the reference of NCERT, which I said we should consider. This is perfect now. ध्यान से देखेंगे. Origin of universe. When I take reference of origin of universe, some pointers very important here, so concentrate and highlight it. Origin of universe की जब हम बात करते हैं, so we take into reference Big Bang theory. और ये Big Bang theory जो है ना, ये सबसे important और सबसे accepted है. तो nebular hypothesis, I'll just come to that. 1 मिनट का समय दो. Big Bang theory, most accepted model. थियरी मॉडल, मतलब अभी भी हम इसको 100% रिकॉग्निशन नहीं देकर एक कंसेप्ट के तौर पर जज कर रहे हैं. आई हैव गॉट दिस एज मोस्ट एक्सेप्टेड, रीजंस बिहाइंड सब कुछ लिखा है यहां पर. इसको समझाने से पहले, देयर हैज बीन मल्टीपल अटेम्प्ट्स, देयर हैज बीन मल्टीपल स्कॉलर्स who have attempted to create out the approaches, the concepts from quite historical times, how the universe, does our solar system originated. तो बहुत सारे concepts हैं जो we come across. We have got nebular hypothesis, we have got tidal hypothesis, These hypotheses do have their share of legitimate values. They are not totally discarded, but Big Bang is something that has been identified to be mostly accepted with least share of controversies, least share of counter debates. तो आप नेब्यूलर हाइपोथेसिस की बात करते हो, चाहे आप टाइडल हाइपोथेसिस की बात करते हो, आप अल्टीमेटली बात करते हो दैट द स्कैटर्ड प्लैनेटेसिमल्स, scattered matter, scattered gases, scattered solid particles eventually were subjected to accretional forces generating more defined constituents, जिसको हमने कहा 5% का ordinary constituent of our galaxy. But because Big Bang is the most identified, followed, accepted, and what is the reason behind, we are understanding it. It says, number one, and each of them is very important for us to apply, that universe began about 13.8 billion years ago. Number two, at this very beginning point, all matter, सारी चीजें शुरू में definition में ले लिया, all matter, energy, space, time, important expression आ रहा है, ध्यान से देखेंगे, were concentrated in extremely hot and dense point. It is called singularity. 13.8 billion years ago. जब आप बात कर रहे हो सिंगुलैरिटी की, आप क्या जस्टिफाई कर रहे हो? यूनिवर्स विच इज आइडेंटिफाइड टू बी ऑल एनर्जी, स्पेस, टाइम, मैटर, वो सब एक बहुत स्ट्रॉन्ग, हॉट, डेंस पॉइंट पर था, सिंगुलैरिटी. एंड नंबर 3, this singularity did not explode into empty space. पहला स्टेटमेंट ही आज के सेशन में यही बात किया है. सिंगुलैरिटी का एक्सप्लोजन एम्प्टी स्पेस पे नहीं हुआ. आप जब एक्सप्लोजन विजुअलाइज करते हो तो आप कैसे विजुअलाइज करते हो कि कोई चीज रखी हुई है और वो फट गई, तो वो कोई एम्प्टी स्पेस में इट हैज एक्सप्लोडेड आउट? नो. यहां पर एक बहुत इंपॉर्टेंट एक्सप्रेशन है, इसको ध्यान से नोटिस करेंगे. इंस्टेड space itself began expanding. This is important and very important. Universe denotes expansion of space itself. It is not expanding in any vacant or open space. It is expanding itself. And this expansion is what we call Big Bang. So जब आप expansion, and there are the evidences which are being identified in support of it. So origin of universe की origin को आप 13.8 billion years, singularity, and singularity there was explosion. Singularity denotes that state where all the matter, energy, space were concentrated into extremely dense single point, right? And then it exploded, not into empty space. It exploded itself. Space itself started expanding. ये चीज ध्यान में रखनी है. That helps us to visualize what universe is all about. In spite of the fact that we are not astronomers, we are not physicists, we are just taking it from the perspective of foundation of physical geography as general studies requirement. What are the evidences that have been charted out by different scholars in regards to Big Bang? इसमें जो सबसे important purview है, हम इसको associate करते हैं evidences cited by Hubble law लिखा है point 2 पर हमने. Cosmic, number 1, I'll put it as A. Cosmic microwave background, CMB बोलते हैं, faint glow left from the early hot universe. Because when I take up the reference of expansion right here, space itself began expanding. It by default will be resulting into the faint glow. Number 2, that has been associated with Hubble's law, expansion of the universe, galaxies moving away and space still stretching. Galaxies are continuously moving away from each other. Galaxies are continuously moving apart, away from each other. They are ever expanding, and that is justifying what? That Big Bang has taken place and is effective even now. 13.8 billion years have passed by. And the very interesting and something which we all can easily say imagine as well is abundance of elements as observed hydrogen helium ratio matches the prediction. Galaxies में आप जब universe, I'll just take you to the constituents of universe. जब आप गैलेक्सीज के कॉम्पोजिशनल कॉन्स्टिट्यूएंट की बात करते हैं, आप स्टार्स के कॉम्पोजिशनल कॉन्स्टिट्यूएंट की बात करते हैं, यू फाइंड हीलियम, हाइड्रोजन इन अबंडेंस, which further justifies that from singularity, banging, and explosion marked up the origin of universe is precisely the justified factor. मेरे ख्याल से ये pointer sufficiently justifiable है to understand Big Bang as an approach, Big Bang as a model, as a theory in helping us understand origin of universe. No need to get into the further details. When I take reference of universe and its development, we also take into account distinctive stages of expansions and characteristics. तो ये जो आपका stages है, अच्छा ये भी chronologically बहुत लंबे चौड़े phases में divide होता है, but as I said, we don't need to get into leaflet जो attach किया है. I have added some of the phases that has been justified. 8 to 9 stages have been highlighted by different scholars. But what I'll advise is that when I take expanding universe, universe is ever expanding, and this expanding universe marked up the beginning of first stars and galaxies approximately 200 million years after Big Bang. And the first star or galaxies का generation हुआ है that basically gravity pulled matter together to form stars, galaxies and planets. इसी को हमने कहा था accretion. Accretional effects. And modern universe जिसको आप associate कर रहे हैं with the reference of Big Bang, 13.8 billion years. Expansion is continuing. About 5 billion years ago, dark energy began to dominate, accelerating expansion. Today, we have got galaxies, stars, planets, life as its constituent. So, origin of universe and its expansion is something that is identified to be in a very long chronological purview. And I just need to give myself understanding of that from singularity to a big bang, big explosion, explosion of the space itself resulted into the formation process of galaxies, of solar systems, planetary systems, distinctive constituents of multiple varieties of stars, and all these processes are still on, and universe is on ever expansion. Are we supposed to talk about the infinite universe with dark energy? No, we are required to talk about that very elementary, very restrictive constituents that make sense for us as planet Earth, dwellers of planet Earth, and as understanding of how planet Earth derives its characteristics from the overall characteristics of universe. थोड़ा सा fast forward mode पर ले जाकर अगर आपको ऐसे समझाएं that if I take reference of singularity and explosion and ever expanding, तो उसके तो it is infinite space. अब infinite space में तो आप कहीं पर भी कोई एक point नहीं pick up कर सकते हो, तो you have to justify it to the common element. तो common element पर आप आ गए तो you will talk about galaxy. So I should talk about Milky Way. Milky Way is my galaxy where I have got my solar system. My solar system has got sun at its center. Sun is accounting for more than 99% mass of my solar system. इसका और जैसे से हम solar system के periphery में चलते चले जाते हैं, we are having on more of Jovian planets and then the cloudy spheres. इसका मतलब क्या? More towards center, dense, more towards periphery, sparse. प्लैनेट अर्थ का स्ट्रक्चर भी तो ऐसा ही है, हम सब जानते हैं ना. हमने इसके बारे में बात नहीं करी हमारे सेशन में, कमिंग सेशंस में बात करेंगे. मोर आई गेट इनटू द इंटीरियर्स ऑफ द अर्थ, आर वी नॉट हैविंग मोर डेंसर लेयर एंड आउटर में मोर लाइटर? आप पढ़ते हैं ना, निकल एंड आयरन एंड सिलिका एंड एल्यूमिनियम. सो बेसिकली इस तरह के पॉइंटर्स के लिए आप अपने आप को कॉन्फिडेंस भी दे सकते हो एंड यू कैन अप्लाई द लॉजिक. आई वांट टू स्लाइड टू When I talk about universe, जहां से मुझे इसके बारे में पढ़ना चाहिए, मतलब universe is ever expanding, समझ में आ गया. Universe is ever expanding from its singularity state, समझ में आ गया. It has facilitated accretion and development of galaxies. So, what exactly is the structure of universe? It is infinite, it is ever expanding, समझ में आ गया. But what exactly it is comprised? क्या ये randomness वाली चीज है? बिल्कुल नहीं है. ये बहुत इंपॉर्टेंट है, ध्यान से देखेंगे. When I take up reference of structure of universe, I identify, and this is important class, universe is not random. It has got hierarchical structure. It has got grades. It has got rank. हायरार्की है, टीयर है. आपने कुछ सेशंस पहले पढ़ा और हमने PYQ भी हैंडल किया था. Tier 1, Tier 2, Tier 3. So you are ranking them in accordance to their population, है ना? वैसे यहाँ पर hierarchical structure है where matter is organized in layers from the smallest to the largest. The smallest is star and largest are cosmic webs. Cosmic webs by default are out of our radar. We don't take that into our study in general principles of physical geography, but structure of universe incorporate grades, hierarchy, ranks. और इसी हायरार्की को अगर आपने डिमार्केट आउट करना है तो you have to take into reference galaxies. So we say universe is comprised of galaxies. Galaxies is incorporating stars and have planetary systems. Galaxies को आप कैसे डिफाइन करते हैं इसके बारे में बात कर रहे हैं. दोबारा से बोल रहे हैं, स्ट्रक्चर ऑफ यूनिवर्स की जो कैरेक्टरिस्टिक्स है क्रिस्प एंड क्लियर आपके सामने लिखी हुई है. It is not required to go beyond that. It is hierarchical, involving stars and involving cosmic webs. मतलब आप इसको लोएस्ट से हाईएस्ट रैंकिंग लेवल्स पर डिमार्केट कर सकते हैं. How are we as physical geographers concerned with them? Physical geographers take into account three principal constituents out of it. Galaxy. गैलेक्सीज को जैसे ही पिकअप करते हो और कहते हो इट्स ह्यूज सिस्टम ऑफ स्टार गैस, डस्ट एंड डार्क मैटर. मतलब हमारे लिए यूनिवर्स की स्टडी को स्पेसिफिकेशन मिलता है गैलेक्सीज से. एंड गैलेक्सीज आर आइडेंटिफाइड टू बी द ह्यूज कॉन्स्टिलेशन, ह्यूज कॉम्बिनेशन ऑफ स्टार गैस. एंड व्हेन आई टेक रेफरेंस ऑफ इट्स टाइप्स, अभी लेकर जा रहे हैं, मिल्की वे एक बहुत इंपॉर्टेंट कॉन्स्टिट्यूएंट है. हम मिल्की वे गैलेक्सी से रिलेट कर रहे हैं. एंड कंटेन्स बिलियंस ऑफ स्टार. गैलेक्सीज के कितने टाइप्स हैं? आई एम जस्ट टेकिंग यू देयर. देयर आर एटलीस्ट 3 डिस्टिंक्टिव टाइप्स. 4 तो फिर अदर वेरिएबल शेप करके आप बना सकते हो, बट देयर आर 3 डिफरेंट टाइप्स ऑफ गैलेक्सीज दैट कैन बी आइडेंटिफाइड. When I talk about galaxies comprised of billions of stars, so automatically मेरा constituent number 2 आ जाता है stars. क्रिस्प इंफॉर्मेशन इस स्लाइड पर है, आगे चलेंगे तो डिटेल्स पर आएंगे. तो मेरे गैलेक्सीज के कितने टाइप हैं वो हम पढ़ते हैं. उसके बाद जब स्टार्स के बारे में बात करते हैं तो हॉट एंड ग्लोइंग स्फेयर्स ऑफ प्लाज्मा. 2025 का सबसे मेजर रिकॉर्ड हो गया सोलर कोरोनल मास इजेक्शन, जिसको इस बार तो मीडिया ने सोलर टोर्नाडो तक का नाम दिया है. सो बेसिकली व्हेन आई टॉक अबाउट स्टार, स्टार इज दैट ग्लोइंग स्फेयर्स ऑफ प्लाज्मा which is continuously generating and emitting heat. And when I take up reference of star, they by itself make an important domain of study of universe, because I have got multiple varieties and categories, जिसमें main sequence आपको जरूर समझाएंगे, as our sun belongs right there. Okay, formed by the fusion, nuclear fusion of hydrogen into helium. Stars are principally comprised of hydrogen, helium. And then number 3, planetary system, जहां पर हम अपना लिंक क्रिएट करते हैं टू गेट इनटू terrestrial planet, our planet, Earth. So planetary system with planet, moon, asteroid, comets, etc. as our solar system. So structure of universe is hierarchical. It is principally comprised of galaxies, stars, and planetary systems. We are taking examples of each one of them one by one. Galaxies. So पिक्टोरियल होने से थोड़ा सा समझने में आसानी रहती है, इसलिए आई हैव इंसिस्टेड दैट वी आर लर्निंग इट लाइक दिस. गैलेक्सीज इमेजेस भी बचपन से बनाते रहे तो कुछ ऐसा ही बनाते रहे. When I take up reference of galaxies, there are three principal types, as I said in the beginning. There are three principal types of galaxies that we identified. एक को बोलते हैं स्पाइरल, नेबुला जैसा. एक आपको दिखाई दे रहा है इलिप्टिकल, एंड देन इरेग्युलर. कोई शेप नहीं है, आप जो शेप इमेजिन करना चाहो आप वो शेप इमेजिन कर सकते हो. कैरेक्टरिस्टिक्स को जस्टिफाई करना है, एग्जांपल्स को जस्टिफाई करना है, स्टेटमेंट बेस्ड क्वेश्चंस एनकाउंटर किए जा सकते हैं. स्पाइरल गैलेक्सीज आर फ्लैट रोटेटिंग डिस्क with spiral arms bending outward from a central bulge. आपको बता दिया, it is more of like a nebula, so it has to bulge out from the center. Lots of gas, dust, and young stars. When I talk about spiral galaxies, they have got young stars. Young stars, they are just active in their formation phase. I'm coming on to a diagram to help you explain that. Milky Way galaxy is the example. So we basically are concerned with spiral galaxy as we belong there. So Milky Way is an example of spiral. Elliptical, shape is elliptical. I have to give this much of the variation. Oval round भी हो सकता है. Smooth and featureless है. It is largely old star, very little gas and dust. Basically यही चीज तो justify करेगा ना that you have got spiraling arm as you are majorly comprised of gas and dust. अब इलिप्टिकल में आगे ओल्ड स्टार है, गैसेस और डस्ट जो है बहुत कम है, तो यू विल बी हैविंग मोर स्टेबिलिटी ऑफ योर कैरेक्टरिस्टिक्स, है ना, एंड ऑलमोस्ट नो स्टार फॉर्मेशन. And when I talk about irregular galaxies, there is no shape, chaotic appearance, lots of gas, dust, active star formation. So यहाँ पर भी active star formation है, यहाँ पर भी active star formation है. Shape is more defined with spiral, irregular shape is not defined. Milky Way galaxy is an excellent example of spiral galaxy. तो आप अगर इसको डिस्टिंक्टिव पॉइंट में याद रखने की कोशिश करेंगे, एकदम जिसको कहते हैं ना मगिंग अप, ब्लाइंड मगिंग अप, वो कहीं पर भी हेल्प नहीं करता, बिकॉज नो वन कैन गारंटी यू कि आपको इसी तरीके का स्टेटमेंट आएगा. एग्जामिनर स्टेटमेंट को मैनिपुलेट कर सकता है. और आप अपना लेटेस्ट प्रीलिम्स एग्जामिनेशन का क्वेश्चंस देखो, आपको 3 स्टेटमेंट्स को देकर पहली बार थोड़ा और ज्यादा कंफ्यूजिंग रेफरेंसेस ऑफ 1 इज एक्सप्लेनिंग 2 एंड 2 इज द करेक्ट एक्सप्लेनेशन ऑफ 1 एक्सेट्रा करके जनरेट किया. तो जब तक आपके दिमाग में क्लैरिटी ऑफ द कंसेप्ट नहीं है तब आप क्लियर नहीं करोगे. Why I am so strongly talking about prelims, because I have told you in the very beginning of the session, इस टॉपिक का प्रोमिनेंस मुझे कभी दिखा नहीं और इस टॉपिक का प्रोमिनेंस कभी होगा भी नहीं व्हेन इट कम्स ऑन टू मेन. ये फिजिकल ज्योग्राफी के डोमेन से बाहर जाता है, बिकॉज फिजिकल ज्योग्राफी और ज्योग्राफी फॉर दैट मैटर is a study of terrestrial phenomena, not celestial phenomena. But as geographers, we are supposed to take reference of many things around us, and we definitely do not remain ignorant. We definitely do not remain ignorant towards what exactly is the characteristics or factors which is going to influence one way or the other to us. So I should be aware of. We are part and parcel of a universe which is largely accepted to have developed as Big Bang 13.8 billion years ago. We identify that universe is ever expanding. We recognize that universe is comprised of hierarchical structure, which is principally made up of galaxies and stars along with planetary system. There are three principal types of galaxies identified. Spiral galaxy is the characteristics of our galaxy, Milky Way. Otherwise, we can have elliptical or irregular, where I don't have any defined shape, but the galaxies can be demarcated. तो ये सारी चीजें आपकी नॉलेज में होनी चाहिए एज अ ब्रीफ क्रिस्प इंफॉर्मेशन. ठीक, ओके. After learning that there are three types of galaxies, अब थोड़ी सी बात कर लेते हैं जल्दी से स्टार्स के लिए. Whenever I talk about stars, I identify them to be the most luminous. आप जब भी डार्कर स्काई एंड स्टार्स को इमेजिन आउट करते हो, यू टेक देम टू बी द मोस्ट ल्यूमिनस कॉन्स्टिट्यूएंट्स इन द universe. They are identified, they are known for their luminosity because they are continuously generating heat energy. They are active nuclear fusion location. Life cycle pathways of stars, ज़्यादा डिटेल्स में नहीं जाएंगे. All these stars are identified to be having certain defined life cycle. जैसे हमने कहा, spiral galaxy में there are many origins of the star. Stars are in their beginning phase of genesis. तो star के भी development, maturity and declining phases होते हैं. Stars are also identified of variable types, largely in terms of the age into which they are. Stars are also identified in reference to their color, yellow, bright red, white dwarfs. They all are correlated basically with which stage of the life they are in. So जब भी हम बात करते हैं stars के लिए, after galaxies are principally dust and stars. So stars को आप essentially categorize करते हैं दो ग्रुप में. तो इस स्लाइड से आप ये पिकअप करें, फिर हम आपको आगे लेकर चलते हैं. और दोनों ही ग्रुप में आपको अल्टीमेटली ये वाली पॉइंट को दिमाग में रखना है. लो मीडियम मास स्टार्स, they are luminous bodies, they are giving you continuous luminosity, they are twinkling. But when it comes on to the other characteristics of stars, so it is low and medium and massive. और जब आप इनके डेवलपमेंटल स्टेजेस की बात करेंगे, सो फ्रॉम नेब्यूला टू प्रोटोस्टार टू मेन सीक्वेंस, यहां पर स्टार जो है वो अपना मैक्सिमम लाइफ स्पेंड करता है. सो मेन सीक्वेंस that converts to red giant, planetary nebula, white dwarf, possibly black dwarf, star mark. थोड़ा सा ध्यान से नोटिस करना, हमारा सन यहां पर है. सन इज इन द लो मीडियम मास स्टार. मैसिव स्टार का जो लाइफ साइकिल है वो भी नेब्यूला से है, प्रोटोस्टार से है, मेन सीक्वेंस. तो फर्स्ट 2-3 सेम हो गया. इट्स रेड सुपर जायंट, सुपरनोवा, न्यूट्रॉन स्टार और ब्लैक होल, बिकॉज दे आर ऑफ देयर बिग साइज. सो आप ये रेड सुपर जायंट, आई पुट इट इन बबल, और यहाँ रेड जायंट, इसको आप ट्रांजिशन लेकर स्टेजेस को मॉडिफाई कर सकते हैं. और ये स्टेजेस का मॉडिफिकेशन जो है HR डायग्राम बोला जाता है इसको. ये HR डायग्राम की सारी डिटेल्स, एवरी टाइप ऑफ स्टार्स आपको नहीं याद रखना है, बट देयर शुड बी द क्लैरिटी अमंग ऑल ऑफ अस as how exactly we categorize the stars in terms of their size, medium mass, low mass, massive, and in terms of their sequence of development. दोनों चीजों को. तो 2 मिनट के लिए इसको देखें. This is your HR diagram. This diagram incorporates contribution of 2 different scholars and identifies the temperature along with the luminosity as the 2 scales to distinguish between different types of stars. आप बहुत ध्यान से देखेंगे, इसमें समझना मुझे ये मेन सीक्वेंस. Main sequence basically is the time span where star has maximum of its lifespan. More you are taking cool and bright, ये सारे जो चारों extremes हैं उनको बॉक्स कर देते हैं. Cool and dim, आप टेम्परेचर को टच करें 2500. Cool and bright, it is more towards red. Hot and dim, hot and bright, it is more towards purplish. Sun is right here. Luminosity is rate of energy output, that is wattage. The sun output is about 4 into 1026 watts. Very important statement based questions बनते हैं. The surface temperature of star and its color are directly tied to each other. Star surface temperature and color are directly tied to each other. And when you try to take that into consideration, notice करो हमने आपको spectrum में already दिखा दिया. Hotter stars have a peak color output towards blue. Cooler stars peak towards red. So whenever I talk about HNR diagram की technicalities बहुत inbuilt है. They are quite detailed. It's wrong for me to say that it is easy to comprehend. Difficult है. But as general awareness holding individual, if I try to use HR, not taking up the reference of the distinctive categories of the star, एक दो sample ले सकते हो आप. जैसे हमने क्या आपको कह रहे हैं red giants. So red giants are basically oriented towards what? Spectrum of red. So they are more touching towards cool and dim, bright, cool and bright. So that you have to keep in mind. So HR diagram basically मुझे अब मेरे luminosity के spectrum के 4 extreme दिखा देता है. ये चारों एक्सट्रीम को आपने कैसे जज कर लेना है, बस इसको अपने दिमाग में रखेंगे. सन इज समवेयर एट द सेंटर. तो ना तो हम एग्जांपल है एक्सपोनेंशियली कोल्ड, ना तो हम एग्जांपल है एक्सपोनेंशियली हॉट. इसलिए सन इज एन एक्सीलेंट केस ऑफ मेन सीक्वेंस स्टार which is incorporating something in between the two extreme. कूलर स्टार जो है वो आपको रेड स्पेक्ट्रम ज्यादा देगा, हॉटर स्टार जो है वो आपको ब्लू स्पेक्ट्रम ज्यादा देगा. एंड इफ आई रीड फर्दर, अदर टेम्परेचर कलर्स आर in between. But a peak in the middle, green, it is also putting out lot of blue and red, and we try to take it up. यहाँ पर ये intermix होकर multiple colors, and we take it up as white. जो आप कहते हैं ना vigor and spin it up and it gives you a look of white, वाला point. So multiple luminosity HR diagram. Maximum of the stars, whether they are into the low or medium mass or into the huge mass, big mass stars, can easily be arranged into this category. Am I supposed to get into the every stage of star formation? My answer is yes, but at a very general sequence. And this general sequence is very well derived from HNR diagram. Our sun is right there at main sequence star. प्लानिटरी सिस्टम. रिमाइंड योरसेल्फ. आगे बढ़ने से पहले फटाफट से रिमाइंडर लेते हैं. When I talk about universe, I talk about universe to be hierarchical, comprising of galaxies, stars, and planetary system. Galaxies can incorporate 3 types. Stars can have multiple grade. On the basis of their mass, we can categorize them into low से medium and big. And luminosity में HR scale पर आप उसको apply कर सकते हो. As more towards blue, as more towards red giants, and something that is main sequence. तो आपने elliptical, स्पाइरल, इरेगुलर गैलेक्सी समझ ली, आपने स्टार के मास बेसिस समझ लिए, आपने स्टार की ल्यूमिनोसिटी बेसिस समझ लिए. तो अब जो आपकी यूनिवर्स में जो हायरार्किकल स्ट्रक्चर लेकर यूनिवर्स अपने कॉन्स्टिट्यूएंट में गैलेक्सीज एंड स्टार्स एंड प्लैनेटरी सिस्टम लेता है, automatically we have reached to planetary system. Or the galaxy to which we belong, Milky Way, spiral hai. Our sun is main sequence category. तो इसकी luminosity में ना तो ये red giant को touch कर रहा है, ना तो ये white dwarf की तरफ जा रहा है. It's something which is a main sequence star, so sufficiently warm, but not that warm. Surface temperature of sun 5,500 degrees Celsius. So it by default is a main sequence star. And planetary system की definition जो होती है वो है a star and its orbiting bodies. तो by default मेरा planetary system जो होगा मेरा solar system है, that is how I'll be learning it on. So the solar system is a planetary system of Milky Way galaxy where we have our sun, which is G category main sequence star. Eight planets, multiple moons, dwarf planets, asteroids, and all bound together by solar gravity. तो मुझे यहाँ से कहीं पर थोड़ा सा what is associated with geography or geographical approaches justification मिलना शुरू होता है. क्योंकि जैसे आप कहते हैं ना planetary system, so you try to take into consideration the constituents which is associated with geography and geographical approach of study. So when I take up account of planetary domain, कि what are the planetary constituents है ना of solar system, तो इसके लिए हमने यहाँ पर पहले हम आपको सन समझा दें, उसके बाद फिर हम प्लैनेटरी सिस्टम लेके जाएंगे. आई हैव इंक्लूडेड सन का important characteristics, which type of star sun is, main sequence, किस category of luminosity में आएगा. It is coming in the luminosity which is neither too cold nor too hot, neither too bright nor too dim. मतलब it is something which is in between. So very elementary constituents हमने already लिख दिया था. Main sequence star है G type. It is primarily comprised of hydrogen and helium. Do remember one thing, and that is very important for all of you to handle, कि जब आप compositional constituents of star के बारे में बात करते हैं, it may have distinctive compositional share. यहाँ पर specification को pick up कर लेना. 74% hydrogen by mass. Helium is about 24%. And that is the reason main sequence. There is the trace amount of other. आपने 74 and 24% ले लिया, तो it has to be trace. We do have carbon, oxygen, nitrogen. Whenever we talk about sun, we take a preference of sun and sun's surface. अभी थोड़ी देर पहले आपको बताया that the photosphere of sun is correlated with coronal mass ejections. हम इनको बहुत easy terms में क्या बोलते हैं? Solar flare. And these solar flare activities basically justifies important impact on the overall atmosphere, overall planetary wind system, and overall climatic system for planet Earth. आप सबने मिलानकोविच cycles के बारे में सुना होगा. Milton Milankovitch was a Siberian scholar who devised a few cycles to identify natural causes of climate change. I'm not taking you there right now. I just want to put one point further forth. So Milankovitch cycles identifies one cycle to be the solar output variation. And solar output variation मुझे एक point का reminder देता है that sun as a star is continuously generating and emitting heat. Sun is continuously generating and emitting heat, and this generation and emission amount by default do not mark up constant level. It fluctuates. So that is the reason we do generate out, and it is happening inside sun. So what is coming out from sun's photosphere is identified to be with two different domains. One is called coronal mass ejection, which is associated with solar flare, and two is called sunspot activities. So solar coronal mass ejections, solar flare activity, solar tornadoes have always been associated with interglacial periods as experienced in planet Earth. And whenever I talk about sunspot in the cyclic manner, it has been associated with glacial period. So solar output variations do involve its important role, effect onto the climatic system of planet Earth. तो जो हमने आपको कहा celestial study geography नहीं है, लेकिन celestial studies के हम ignorant नहीं रहते. We have to take into consideration celestial study, and this is one important case. 149 million kilometers approximately. And that perihelion and ephelion when we talk about climate, so we'll talk about that later. Okay, this is sun, and then we get on to our principal constituent of solar system. Principal constituent of solar system, 8 planets, 4 of them terrestrial, and 4 of them gas giants, Jovian planets. And as we take up the demarcation of them, here, Mercury, Venus, Earth, Mars versus. So when I take reference of Mercury, Venus, Earth, Mars, we are taking them to be examples of inner planets, terrestrial planets. And when I take up Venus, Jupiter, Saturn, Uranus, Neptune, we are talking about gas giants, peripheral planets. अब यहाँ पर कुछ एलिमेंट्री इंफॉर्मेशन विच आई हैव जॉटेड डाउन हो जल्दी से आपके बारे में बात कर लेते हैं. प्लानिटरी सिस्टम में इंटरनेशनल एस्ट्रोनॉमिकल यूनियन IAU, after Pluto was deleted out from the list of the planet, so there was a defined definition given to us, and probability of the question is not ruled out. How do I define planet in the planetary system study? So planet will be a celestial body that is in the orbit around sun, perfect, is having sufficient mass for its self-gravity to overcome rigid body force and assume hydrostatic equilibrium. It should be having sufficient body mass to generate out hydrostatic equilibrium, and that is largely reflected in defined shape, largely circular. Some modification in circular domain can be justified. And number 3, and I want to put a star mark to it, has cleared its neighborhood. Accretional process is completely done. So 3 fundamental characteristics, once satisfied as per International Astronomical Union, you are designated as planet. And this is where we demarcate the 8 categories of planets. इमेज हमने देखा है, बचपन से हम पढ़ते हुए आए हैं. कैरेक्टरिस्टिक्स पर जब क्वेश्चन आता है तो कई बार हम अटक जाते हैं, तो बस एक सिंपल स्विफ्ट रिवीजन जरूर ले लेना है. व्हेनेवर वी टेक अप द रेफरेंस ऑफ planets and their characteristics, आप इनको इन्हीं पॉइंट्स पर जस्टिफाई कर लें. And I think that makes precisely all the important. इसके बाद आप एग्जांपल्स ऐड कर लो. If I'm terrestrial planet, I'm inner part of solar system. Where I'm located? Inner part. What is my composition? I'm mostly rocky, metal cores. What is my size? I'm normally small and dense. I'm normally small and dense. आप इसको बस कंपैरिजन में डालिए. अभी हम आगे नहीं बढ़ रहे, हम 3 पॉइंटर्स को लेकर जोवियन प्लैनेट्स को कंपेयर करें. I'm in the outer part of solar system. I'm majorly made up of gas and ice. Hydrogen, helium, methane, ammonia are the constituents that makes me, है ना? And when I take up reference of their size, they are immensely large and low density. अभी थोड़ी देर पहले इमेज दिखाया आपको. Gas giants, कोई comparison ही नहीं है size का. Inner planets are significantly small in size and they are much rocky. Outer planets are bigger in size and are majorly ice and gases. Characteristics, they all are planets, so they have satisfied the threefold criteria. लेकिन वो तीन-fold criteria में भी they are different from each other. So you draw the boundary line and you take up the demarcation. इसके आगे characteristics पर जाएंगे तो atmosphere thin varied. अब बोलोगे thin, अर्थ का atmosphere तो 10,000 किलोमीटर तक जाता है. Thin तो नहीं हो सकता, but वो thin in comparison to outer, thick and stormy. Moons, that is natural satellites and rings. When I talk about moons and natural satellites, I have got inner planets with very limited, few. Rings तो बिल्कुल नहीं है. And outer में तो many. Saturn and Jupiter जैसे planet के साथ तो आप associate करते हो 70, 80 satellites, moons, and of course the rings. And surface, as I said, is solid. यहाँ पर rocky है, craters है, volcanoes है. यहाँ पर no solid surface. So characteristics of 8 planets of our planetary system after Sun associated with 99% plus of the total mass of solar system is inclusive of planets. And when I take up reference of planets, I can easily divide them into two categories, inner and outer. They all justify, they all satisfy IAU's threefold definition of being a planet. अब इसी point पर add करो, what are the other constituents of the solar system? Other constituent of solar system will include sun हो गया, planets हो गए, तो इसको number 3 count कर लेते हैं, dwarf planets. They also satisfy the first two characteristics. Matlab, I should be also orbiting around sun, perfect. I should also have hydrostatic equilibrium and have attained certain shape, rounded shape, largely perfect. But I have not cleared my neighborhood. And this was the reason that Pluto was snatched of the status of being a planet. And we have other dwarf planets. They are not full planets. So they're dwarf planets. So Pluto, Eris, Homa, Ceres. These are the good examples that we can identify as the constituent of solar system. So I'm having 2 versus 1. I have not cleared my neighbors. Neighborhood is not clear, and that is the reason I don't qualify it. Other objects, all other objects, अब इसको 4, 5, 6 कर लो या सिर्फ 4 ले लो. All the other objects, except of course satellite, orbiting sun, will be called small solar system bodies. So let us put it this way. Solar system is example of the planetary system with which we are concerned. It belongs to Milky Way, which is the example of spiral. And when I take reference of solar system, the planetary system, it is comprised of sun, of course, which is G main sequence star. It is comprised of 8 planets already compared, inner and outer. It is comprised of dwarf planets, we have understood it, and it is comprised of small solar system bodies. And these small solar system bodies, अब यहाँ पर भी ना क्वेश्चन बड़े आराम से बनते हैं. Asteroids, they are planetoids. Asteroids are planetoids. Asteroids are potential planet building material. Asteroids are potential planet building material. Minor. They are identified as minor planets. They are identified to be those planet building material that could not fully get accreted. They form the boundary between inner and outer planets. So I found them as the belt. Of course, they are orbiting the sun. So asteroid belt demarcate the inner and outer planet ka boundary. Comets are the small solar system bodies which are comprised of ice, dust, and rocks. And as they mark their movement, it's the process of sublimation that basically makes them create that tail. Comets are always known for their typical tail. When it comes to meteoroids, different from asteroids, meteoroids are much smaller size than asteroids. They are small rocks in space, and meteoroids can be demarcated as meteor and meteoroid. And these are the expressions where I can have possibility of multiple choice question. When I reach Earth's atmosphere and create, because of the frictional drag burning, create streak of light, I'm referred as a shooting star. And if I survive atmosphere and fall, crash down on the surface of the earth, I'll be called meteoroid. And meteorite is basically associated with impact craters. अभी हमारे रामसर साइट की लिस्ट में बहुत पॉपुलर लेक है लोनार. Of its color change, it came into news. बिल्कुल recent example नहीं है, but recent case ही है. It is an impact crater which has been because of the impact of meteoroid touching the ground, surviving. इसके अलावा कूपियर बेल्ट और ऊट क्लाउड्स को मिस नहीं करना चाहिए when you are taking the fundamentals or elementary approach of solar system. कूपियर बेल्ट को कहते हैं icy bodies beyond Neptune, and oot clouds are spherical clouds of comets that basically define outermost limit of solar system. सन की ग्रेविटी फील्ड का जो आउटर मोस्ट लिमिट है वो ऊट क्लाउड्स के साथ एसोसिएट होता है. These makes the constituents of our solar system, planetary system. Mercury, Venus, Earth, Mars, asteroid belt, inner planet. I definitely want to close down on this. I have understood universe ever expanding. I have understood universe is infinite. I have understood that universe has got hierarchical structure. I've understood that universe is associated with, say, galaxies and then stars and then planetary systems. Where galaxy Milky Ways are concerned, solar system is our concern. Constituent of solar system we have understood. Now the question is, what exactly do we preempt as future of galaxy? फ्यूचर ऑफ गैलेक्सी को जस्टिफाई करने के लिए तीन चीजें जस्टिफाई करी जाती हैं, तीनों ही बड़ी इंटरेस्टिंग है. ऑफ कोर्स व्हाट वी आर प्रीएम्प्टिंग, ऐसा कुछ हो सकता है. बिग फ्रीज, expansion continues, star dies, energy spreads out. Currently evidence favor endless expansion, heat death. दूसरा प्रोबेबिलिटी, ये सबसे ज्यादा हाईएस्ट परव्यू पर है, expansion reverses, called big crunch. Universe collapses back into the whole dense state. Equilibrium, जहां से आप शुरू हुए थे, stationary phase. तो big crunch is a reversal. It is talking about reversal of what is happening, what we are trying to trace from 13.8 billion years. And तीसरा probability को कहा जाता है big rip. Big rip is expansion becomes so extreme that it tears apart galaxies, stars, and even atoms. One, expansion will continue, energy will be consumed, heat death. This is most likely. Why? Because it is more in compatibility to what we have understood as the planetary system, as the galaxy, or as solar systems so far. However, the other two possibilities are not ruled out. Possibilities, हम इन इसमें probability लेकर चल रहे हैं. We are not sure what will happen. So big crunch or big rip, meaning पता होना चाहिए. So definitely it is there. And by default, this takes us to what will be our focus of study as we take our leap here. हमें पढ़ना ये fundamental principles, salient features of physical geography world means I have to learn planet Earth as ever evolving planet. Planet Earth as ever evolving constituent of our solar system. I'm certainly not saying that other constituents are not evolving, but planet Earth incorporate the characteristics of that dynamism that falls in the jurisdiction of geography. तो बहुत इंपॉर्टेंट पॉइंट पर सेशन आज का खत्म करेंगे और मेरे ख्याल से इससे ज्यादा डिटेल्स में आपको किसी को भी जाने की जरूरत नहीं है. एनसीईआरटी का रेफरेंस लीजिए, अटैच्ड नोट्स है उसको आप रेफर कर सकते हैं. एवर इवॉल्विंग प्लैनेट, टेरेस्ट्रियल स्टडीज ऑफ प्लैनेट अर्थ. अब प्लैनेट अर्थ को आप कैसे कैसे डिवाइड करोगे वो हम अभी बात नहीं कर रहे. इज द डोमेन ऑफ physical geography. So we are a terrestrial planet. We have got one natural satellite. We are having thin, stable atmosphere, thin compared to the other constituent of our solar system. And we definitely have got rocky surface, and that rocky surface is involving ever-evolving combination mechanism of multiple processes. So we'll be beginning our next session with the hardcore terrestrial studies that is associated with planet Earth, the inner planet, the only life-bearing planet, the blue planet of our solar system. Bye-bye from my side.